Hello, linear algebra. This is section 3.1 on invertibility. Let's start with the preview activities. So the first preview activity is solving 3x equals 5 using only multiplication instead of division. So this would be multiplying both sides by 1/3. So if we multiply both sides by 1/3, then we get that x equals 5/3. And the reason we're doing this using only multiplication rather than division is that when we're doing with matrices, we have multiplication, but we don't have division when it comes to matrices. And so to solve for things, we need to multiply by the inverse of something. So in this case, I multiply by the inverse of 3. We'll come back to that idea later. Now, find the 2 by 2 matrix A that rotates vectors counterclockwise by 90 degrees. So here I'm going to draw domain, codomain, switch for drawing the vectors. I'll draw E1 there, E2 there. So the columns of the matrix are where it sends E1 and E2. So in this case, counterclockwise, so T of E1 will be there, T of E2 will be there. And so the matrix A is then the matrix with columns. E1 got sent to E2, and E2 is 0, 1. And then E2 got sent over here, which is the negative of E1. So we throw that into the second column. -1 here, 0 there. That gives us the matrix A that rotates vectors counterclockwise by 90 degrees. Now we're going to find the 2 by 2 matrix B that rotates vectors clockwise by 90 degrees. So again, I'll draw domain, codomain, draw my vectors, E1, E2, but now I'm rotating clockwise. So now T of E1 is there, T of E2 is there. So then B equals E1 got sent to positive E2. So then, silly Ryan. All right, clockwise. Clockwise means T of E1 is here, T of E2 is there. So then my first column is sent to negative of E2, so that would be 0, -1. E2 is sent to the positive of E1, so 1, 0. So that is B. All right. Clockwise and counterclockwise. Important to remember the difference. All right. Now, preview activity 3.1.1.2. What do you expect the product AB to be? Explain the reasoning behind your expectation and then compute AB to verify it. So this should be the identity. Because rotating B is clockwise. We're doing B first and then A. So rotating clockwise, then counterclockwise, by the same angle will cancel out. So verify it. So A was the matrix that had 0, -1, 1, 0. B was the matrix that had 0, +1, -1, 0. Multiplying those, row, column 1, row, column 0, row, column 0, row, column 1. And yes, it is the identity, so checks out. Solve the equation AX equals 3, -2 using Gaussian elimination. So remember, A is our matrix with 0, -1, 1, 0. But then we're going to solve this equation, so we might as well augment it. 3, -2. And then this is a very simple Gaussian elimination, you just swap the rows and you get 1, 0, -2, 0, -1, 3. And then you make the second row negative. So 1, 0, -2, 0, 1, -3. And so that means that x equals -2, -3. Okay? Now, explain how your solution may also be found by computing x equals b times 3, -2. Well, b times 3, -2, that's equal to, b is 0, +1, -1, 0, times 3, -2, equals, so you get -2 there, -3 there. Why does that work? Because b is the opposite of a. It's the opposite of a. So multiplying by b, basically, so you're solving for what x would do that. Well, actually, let's just do this with algebra. So basically, a times, instead of x, put in, so then ax, I'll write it that way. Then substitute for x as b times 3, -2 would equal ab times 3, -2 would equal 3, -2, because a and b cancel each other out. So b kind of prematurely undoes a, so you can solve for x that way. Okay, I think that completes the preview activities, so we'll stop this video there.